Right, this is lesson 7.3, assignment number 1, and it's an example. We're going to find the volume of the solid generated by revolving the region bounded by y equals square root of x equals 0, and y equal 1. So that region will be rotated about the line y equal 1. So the first step is we're going to draw a two-dimensional drawing of the region that we're going to rotate. So this will be a 2D drawing. And we're going to graph y equals square root of x, which will look something like that. X equals 0, which is another name for the y-axis. There's x equals 0 right here. And y equal 1, which would be right here. So we end up with this region. Again, this line right here is y equal 1. The y-axis is also known as x equals 0. And this is y equal square root of x. And if you want to know, for example, what that point is, we could notice that if we plug in 1 for x, we would get 1 for y, so that's the point 1, 1 right there. All right, now we're going to revolve that region about the line y equal 1. So now I'm going to make a 3D drawing, three-dimensional drawing, showing what the three-dimensional figure would look like if we rotated that region around y equal 1, like this. So let me try to draw that next. Something like this. What you want to do is reflect that region over your line of your axis of rotation, or axis of revolution, which is, again, y equal 1 here. This is my x-axis here. This is my y-axis here. So what we're going to do is we're going to revolve that region around y equal 1. So to draw a picture of that, we're going to rotate it, or reflect that region up over y equal 1. To make it three-dimensional, we're going to use an oval here to kind of show that. And so what we really have is a three-dimensional cone, kind of, but it's not going to have straight sides, kind of curved sides. And when you think about it, if we're going to slice that, we're going to slice perpendicular to the axis of rotation. So if the axis of rotation is horizontal, y equal 1, we're going to slice this, use what's called the disk method. If we slice this up into a bunch of pieces, kind of like you're slicing the end of a banana or something like that, or slicing an orange, we'd end up with a bunch of slices that look like discs like this. And the thickness of that disk, the skinny dimension, or the thickness of that disk runs sideways. So that's a change in x because it runs horizontally. So we're going to call that thickness dx right there. That tells me that I want my integrand to be in terms of x, and I want my bounds to be in terms of x. So my bounds are going to go from 0 to 1 right there. We said this was 1 back here, 0 to 1. And I know that I want to use x values instead of y values because of the fact that we're using dx. Now, the radius would run from the center of that circle and always go back to your original curve. So the radius would be this distance right here, from here to here. And to get the radius, we're going to take top curve minus bottom curve. So the radius in this case would be 1 minus the square root of x. The top curve here is 1, bottom curve is square root of x. But you want to go back to your 2D drawing to figure that out. And that's one reason why you want to make sure you make 2 drawings in every problem. So there's my radius, 1 minus the square root of x. Now, to get the volume of this disk, you'd want to take the surface area of that circle times the thickness. That would give you the volume. So to get the surface, you need to use this formula. So we're getting volume here. We're going to take pi times the radius squared. That'll give us the area of the surface of this disk. Then when you multiply it by the thickness, which in this case is a dx, that ends up being a volume of that disk. And then if you want to imagine that you slice this into a whole bunch of little disks, and you want to add all those up, we use an integral to add up those volumes. And we're going to slice from 0 to 1. You always start with your smaller bound and with your larger bound. So in this case, our volume is going to be And this pi you can also move out front. That's a constant that can be moved out in front of the integral. Our radius, we said, was 1 minus the square root of x squared. It's radius squared. The pi is out here. We're going from 0 to 1. Don't forget the dx because that's the thickness of your disk. Next, let's go ahead and take 1 minus the square root of x times 1 minus the square root of x. So I'm just going to FOIL that out here down below. Do some scratch work here. So 1 times 1 is 1. 1 times negative square root of x is negative square root of x. Same thing here, negative square root of x times 1 is negative square root of x. Square root of x, negative square root of x times negative square root of x would be positive x. So I'm going to rewrite this up here. Volume equals pi times the integral. That's an equal sign, not an approximate equal sign. From 0 to 1. And here's my integral. I'm going to put the x for, it doesn't really matter, I guess. I'm going to go 1 minus 2 square roots of x plus x. All times dx. Now, if you were going to evaluate this using a calculator, you would just go ahead and type it in as is. Use Math 9 on your calculator, type in the integral. But if we're going to do it by hand, then we're going to have to find the antiderivative by hand. So the antiderivative of 1 would be 1x. 2 square root of x, let's call that 2x to the 1/2 power here. So to do the integral, or antiderivative, you make that exponent 1 bigger, so that'll be x to the 3/2. Then 2 divided by 3/2, that would be the same as 2 times 2/3, so that would be 4/3. And then the integral of x, make that exponent 1 bigger, so that's x squared, and then 1 divided by 2 would be 1/2. And we're evaluating that between 0 and 1. And don't forget about this pi out front. We'll wait and multiply by pi at the very end of the problem. So volume equals pi. Plug in 1 right here, so you're going to have 1 minus 4/3 times 1 to the 3/2, which would just be 1. So 4/3 times 1 is 4/3. Plus 1/2 to the 1 squared power, that would be 1/2. Minus, plug in 0 here, here, and here, and you'll get 0 in each place. So volume equals pi. Now let's get a common denominator. Let's use 3 and 2. The common denominator would be 6. So we're going to use, for 1, we're going to call that 6, 6. 4/3 would be 8, 6. 1/2 would be 3, 6. So 6 minus 8 is negative 2, plus 3 will be 1/6. So our volume is going to be 1/6 pi cubic units. Cubic units because it's volume. That would be the volume of this three-dimensional figure right here.